Hello all. In this video, I'm going to teach you how to deploy a single CloudGuard gateway, which is the most basic CloudGuard deployment. The single CloudGuard instance will protect all of your Azure workloads. The design I'm going to show you is based on Check Point best practice cloud network security architecture. This architecture would allow you in the future to easily expand and replace the single gateway with cluster or scale set for redundancy and supporting any amount of traffic. I want to start by showing you the workload that I currently have in Azure. I have just one VNet in US East with two subnet and a few workloads. I want to show you two options for CloudGuard gateway deployment. The first one is an option but would limit your ability to expand in the future. So in this first option, to protect your existing workload, you will need to add two additional subnets to the existing workload VNet Spoke 2, subnet internal and subnet external, and deploy the CloudGuard gateway with interfaces in each of those subnets. The problem is that once you want to expand and add new VNets, the only option would be to create a VNet peering to VNet Spoke 02, where you have an existing workload. It would work, but it's not recommended. A better option is to create a dedicated VNet to the CloudGuard gateway and connect the workload's VNet over VNet peering to the CloudGuard VNet. This type of architecture will allow you to expand and connect new VNets to the CloudGuard VNet over VNet peering. The CloudGuard will protect the following traffic flows: incoming traffic from the internet or VPN connections, outgoing traffic, and east-west traffic. Let's deploy the CloudGuard gateway. The Check Point solution is built from two main components, gateway and management. You can install both on the same machine, and this is what we're going to deploy in this environment. The installation type is called Standalone. Check Point has a template in Azure that is going to deploy the VNet, the subnets, and the CloudGuard. Let's connect to the Azure portal and navigate to the marketplace. I will search for Check Point. Bear in mind that Check Point is two words. Select the CloudGuard IaaS. From the software plan, select the single gateway. You will have to create a new resource group. You won't be able to deploy the CloudGuard to non-empty resource group. I will give the resource group the name Secure Hub. The region for the resource group doesn't matter. Anyway, I will set it to East US. I will give the VM the name CloudGuard Single, and I will set a password for the VM. I will click the Next button. I'll set the CloudGuard version to R80.40. I set the license type to bring your own license. I'll keep the VM default size. Feel free to adjust it to your needs. You'll be able to change the type after the deployment as well. I'll set the installation type to Standalone. As I said earlier, this type of installation will deploy management and gateway on the same instance. Click the Next button to move on to the network settings. Create new VNet, CloudGuard-VNet, with address change of 172.168.480/22. Set the front-end subnet to 172.168.480/24. Set the back-end subnet to 172.16490/24. Click OK, and Next to review and create. Once the validation process is complete, click the Create button. Deployment would take around 4 minutes. From the moment the deployment was completed, you will have to wait another 15 minutes for the machine to be ready, as it's running in the background post-deployment scripts. On the Secure Hub resource group, you'll see the resources that have been provisioned by the template. In order to manage the Check Point management server, we will need to download first the latest R80.40 Smart Console package. I will locate the public IP of the instance and I will open it to a connection over HTTPS. I will use the user admin and the password I choose when I run through the template wizard. To download the latest Smart Console, navigate to Upgrades and from there to Status and Actions. And click Check for Updates once the process ends. Download the Smart Console you see under the minor versions and export it to your local machine. In the meanwhile, install the latest general availability jumbo hotfix on the CloudGuard machine. The instance will reboot automatically. The process will take about 10 minutes. Before the instance restart, we will also need to create a static route to Spoke 02 address range. Navigate to Network Management and to IPv4 static route. Add a new route to network 192.168.0.0, mask 255.255.252.0, and gateway 172.16491. Move on and install the Smart Console on your local machine. On the Azure console, we will need to create the VNet peering between the workload VNet Spoke 02 and the CloudGuard VNet. Navigate to VNet. Select VNet Spoke 02. Add Navigate to Peering menu. Add a new peering. This wizard will create peering from VNet Spoke 02 to CloudGuard VNet and also in the opposite direction. Now we will need to create a default route from Spoke 02 subnets to the CloudGuard internal interface IP address. Let's first find the internal IP address of the CloudGuard. The IP is 172.164.9.4. Let's create route table. I will search in the console route table, and I will create a new route table in East US, which is the same reason where Spoke 02 VNet is located. On the subnet menu, we will associate the two subnets in Spoke 02 VNet with the route table I have just created. Now I'll create the default route and point to the internal interface of the CloudGuard. I will also create two additional routes. The first is to route all traffic to network 192.168.0.0/24 to the gateway. The second one is to route all traffic to network 192.168.1.0 to the gateway. Those two static routes will pass all the traffic between the two subnets in Spoke 02 to the gateway. I already know that I will want to publish the internal load balancer that is on the front of my Nginx scale set to the internet. And I will also want to publish the application that is on instance 192.168.1.4. For that, I will add two additional public and private IPs to the external network interface of the CloudGuard instance. Write down the internal and external IP for each application. Now, let's open the Smart Console and configure a policy. I will create a few objects before the creation of the access policy. I'll create a network object that represents the Spoke 02 VNet address range. And I also create an automatic hide NAT for this network. I'll create the external private IP for each one of the applications. I'll create the internal IP for each one of the applications. Now let's configure the CloudGuard network interfaces. ETH0 leads to the internet. I will also set a zone to this interface, which will allow me to use it later on the access policy. ETH1 leads to Spoke 02 address range 192.168.0.0/22. Now I will create access policy rules. I will allow access from Spoke02 subnets to ping any destination on the external zone. I will allow the Nginx 1.4 to access the Spoke02 subnets. I will allow incoming access over HTTPS to the two web applications. And SSH to the Nginx 1.4. I will need to add NAT rules to allow access from the internet to the destination instances. I will add 2 NAT rules for publishing the web applications. And an additional NAT rule for SSH access to the Linux VM Nginx 1.4. To save the changes and commit them to the database, click the Publish button. To push the policy to the gateway, click the Install Policy button. We will wait a few moments till the push policy is finished. Now let's try to connect over HTTPS to our web applications. As you can see, I can access my 2 applications over HTTPS. Now I will try to connect Nginx 1.4 over SSH. I will try to access to the internet by pinging to Google DNS 8888. I will ping an SSH to a host in a different subnet 192.168.1.9. Now let's check the logs to see that we have a log to each one of our tests. And yes, we have it all. I hope you enjoyed this walkthrough lecture. Thank you and goodbye for now.